Okay, today we're going to work on decomposing fractions using area models to show equivalent fractions. In class you'll work on sprints, and just to start out today we're going to find equivalent fractions as review. So the first thing we're going to do is draw a model, an area model, to show 1/3. So let's draw that right here. And we're going to split this up into thirds, and then we'll shade in 1/3. And remember, with the area model we split it up horizontally, so we're going to split this up. Now it's showing us we have the numerator as 2, so that means we should have 2 rows. When they give us the numerator, that tells us how many rows that we should have. So I'm splitting this up, and if you notice I have 1 row, 2 rows. So now I just have to look and see what my new fraction is. So if I look at this, I have 2 shaded parts out of 1, 2, 3, 4, 5, 6 total parts. So my new fraction is 2/6. So I can say that 1/3 is equivalent to 2/6. And so that'll be 1/3 right there. Okay, for the next part, we're going to again draw area models to represent the fraction, and then we're going to find the equivalent fractions. And we're going to find either the missing numerator or the missing denominator. Now it's important when we look at this to figure out the numerator or the denominator, and we're always going to start with the bigger piece. So in this case we're going to start off with 1/2, and I'm going to draw that, and I will shade in half of it. There we go. Now in this case it is showing us the number of rows, so I should have 2 rows. So I'm going to cut this right in half because now I have 2 rows. So I should have 2 shaded parts, which I do. 2 shaded parts out of 1, 2, 3, 4 parts altogether. So that's saying 1/2 is equivalent to 2/4. The next one, I have 1/2 again. So I'm going to draw 1/2, and I'm going to shade that in. And again, my numerator is 4, so that means I want to have 4 rows. I'm going to draw 3 lines across so that I have 4 rows. 1, 2, 3, 4. So that now I have 4 shaded parts, and I should have 4, 5, 6, 7, 8. So that is showing 1/2 is equal to 4/8. Now if I look at this closely, I have 1/2 is equal to 2/4, and I have 1/2 again is equal to 4/8. So I should be able to say 2/4 is equal to 4/8 because that was equal to 1/2. Those are all equivalent fractions. The next one is 1/4. So I'm going to draw that here, and I'm going to break this up into fourths. And I'm going to shade in 1/4. And this time they didn't give me the numerator, they gave me the denominator. So I'm going to count by 4s till I get to 8, so I know how many times I need to split this up. So that's 4, 8. So that's 1, 2 times I need to break that up. So I would have 2 groups to break that up. So I need 2 groups. So I'm actually going to just cut this once in half. Therefore I have 2 groups. Okay, so that should give me 8 parts, because if you remember, the denominator is always the total parts. So that's 1, 2, 3, 4, 5, 6, 7, 8. That's 8 total parts, and in this case I have 2 shaded. So that is 2 eighths. So this is saying 1/4 is equivalent to 2 eighths. The next one is 1/5. So I have to draw 1/5. One, two, three, four, five. That's a little bit big. Let me erase that a little bit here. And okay, and shade in a 1/5. All right. And look, it looks like they gave us the denominator, so they gave us the total number of parts. So if I count by fives, 5, 10, 15, 1, 2, 3. So that means I should have 3 total parts, or 3 groups. So that means I should have 15 total parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that gives me 3 shaded out of 15. So that's showing me 1/5 equals 3/15. Okay, the application problem says, use area models to prove that 1/2 equals 2/4 equals 4/8, and 1/2 equals 3/6 equals 6/12, and 1/2 equals 5/10. And then it says, what conclusions can you make about 4/8, 6/12, and 5/10? Well, where did those numbers come from? Well, 4/8 comes from the first set of numbers. 6/12 comes from the second set of numbers, and 5/10 comes from the third set of numbers. So somehow they want us to draw conclusions about those 3 numbers when we're all done. So first I'm going to draw some area models. So I'm going to rewrite these numbers. 1/2 equals 2/4 equals 4/8, and then 1/2 equals 3/6 equals 6/12, and 1/2 equals 5/10. And I'm going to draw my 1/2 first and shade that in. And that equals 1/2. Then I'm going to draw another one, try to keep them the same size, and I'm going to say, okay, there's my halfway mark, and shade that in, because they're showing that they're equal, so they're equivalent, so I should be able to break up 2/4 from 1/2, or decompose 1/2 into 2/4. So if I break that in half this way, 1, 2 are shaded out of 4, so that's 2/4, so that's showing it is exactly the same. So let me do the next one and draw them the same. There's my halfway mark. Shade that in. They're pretty much the same. And this is going to be my 4/8. And again, it should be equal to 1/2. So let's see, if I go 2, 4, 6, 8, 1, 2, 3, 4. So that's 4 times, if I think 4 times, that's 3 lines across. 1, 2, 3 lines across. It's 1, 2, 3, 4 shaded, so that's right. 1, 2, 3, 4, 5, 6, 7, 8, 8 parts, so that's 4/8, that's right. And all of my shaded parts look the same. So that's showing they're all equal. So I showed that they're all equal. So now I have to do the same thing with the next set of fractions. So I'm going to show 1/2. I'm going to set all of these up ahead of time here. So those are all going to show 1/2. And I'm going to shade them all in. So we're going to notice this is all 1/2. This is 1/2. And this is 1/2. Oh, just like that, this one was 1/2 as well. Maybe I'll set this one up too, because this says it's 1/2 as well. So these ones should be 1/2 as well. So you break this one up, break this one up. So this is 1/2. So this is 1/2. Because when we decompose it, it should show it's 1/2. So now I'll take, and this is 1/2, and this is 1/2. Now I'm going to break this one down into 3/6. So if I'm thinking 1/2 into 3/6, so I go 2, 4, 6. When I count, that's 1, 2, 3 times. So I need 2 lines. 1, 2 lines. 1, 2, 3 shaded, 4, 5, 6. So that's correct. So that's the same amount. So they are equivalent. Now I have to do 6/12. 2, 4, 6, 8, 10, 12. That's 1, 2, 3, 4, 5, 6. That's 6 times. So I have to break this up 6 times, which is 5 lines. 1, 2, 3, 4, 5 lines. So that's 1, 2, 3, 4, 5, 6 are shaded out of 12 total parts. So that is correct. Now I know they're all equivalent because I drew them beforehand, and I know they all equaled 1/2. So that is correct. So now I'm looking at the last grouping. I have my 1/2. Now I have to do 5/10. Somehow I have to decompose this 1/2 into 5/10. Let's see, I go 2, 4, 6, 8, 10. That's 1, 2, 3, 4, 5. So really that's times 5. So I need 4 lines. 1, 2, 3, 4 lines. So that's 1, 2, 3, 4, 5. So that's 5 shaded. 6, 7, 8, 9, 10 out of 10. So that's 5/10. So that is correct. So what the next part is, what conclusions can I make from this? Well, let's see. I think the first conclusion I can make is that 4/8 is equal to 1/2, because I saw that 4/8 was equal to 1/2. 6/12 was equal to 1/2, and 5/10 was equal to 1/2. So I can say they all equal 1/2. I think that's pretty important. And I know that because I started every single one of them with 1/2, and then I decomposed them each time from the 1/2 mark. And my shading never changed. My shading amount was the same, even though I broke them into smaller pieces. My shading always remained the same. So I can say that 4/8 equals 6/12, which also equals 5/10, because they all equal 1/2. Okay, the next part says I can use an area model to show 3/4 is equal to 6/8, or equivalent to 6/8. So I'm going to draw an area model down here, and I am going to shade in 3/4. 1/4, 2/4, 3/4, and I'm going to mark that as 3/4. And then it says, use this model to decompose 3/4 into eighths. So I need to decompose this into eighths. So if I'm thinking I have 3/4 and I need it to be in eighths, I'm going to count 4, 8. That's 1, 2. So I need it to be 2 times, which is actually only one line because that'll give me 2 groups, right? So 1, 2, 3, 4, 5, 6. 6 shaded out of a total of 8. So that means I have 6/8 shaded. Now to write an addition sentence to describe this decomposition, I'm going to show 3/4 is equivalent to how many eighths? Well, to show that, I'm going to write in my 1/8 in here. Now, these are all worth 1/8, but I only want the shaded 1/8 part, which is showing what the 3/4 is equal. So I'm going to do 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. 1, 2, 3, 4. I'm going to have to squeeze it in here. Maybe I'm going to erase it and rewrite it just because I think I'm running out of room. Try again. Equals 6/8. And we can bracket or put parentheses around 1/8 plus 1/8 around every 2, because we know 1/8 plus 1/8, which would be this section here, right here, right here, and right here. 1/8 and 1/8 is actually 1/4. So each one of these little sections like this would be a 4th. So this would be worth a 4th, this would be worth a 4th, and this would be a 4th. So just another way to think about it. So we could say as a multiplication sentence, 3/4 equals 3 times 2/8, because I have one group of 2/8, two groups of 2/8, three groups of 2/8. And I could say that equals 6/8, because 3 times 2 is 6. Or another way to say that is I could say 3/4 equals 6 times 1/8 equals 6/8. Or I could say 3/4 equals 6/8. The next question says, what do these addition and multiplication sentences tell you? This is a great question. Think about it like this. Look at our shaded areas. Did the shaded area change from when I first drew it to now? The red never changed. The number of pieces that I drew increased because the size of the pieces I cut up got smaller. And when we added all of those smaller units, it equaled the total number of the larger shaded units. And when we multiply, it's just easier and quicker to write than all of those addition problems. Okay, the next part says I can draw an area model to represent the equivalence of two fractions and express the equivalence as a sum and product of unit fractions. Number 1, what fraction will you model first using an area model for 2/3 equals 8/12? Well, if you think about it, you always want to start with a fraction that has the larger pieces. That way you can decompose it into smaller pieces. So the fraction with the larger pieces is 2/3. So I'm going to draw that down here. And I'm going to shade in 2/3 of them. So this would be 1/3, 1 out of 3, and this is 2/3. Say 1/3 and 1/3 is 2/3. Now, how can I decompose this? Again, we can count by our denominator, so count by 3s till we get to 12. 3, 6, 9, 12. 1, 2, 3, 4 times we counted by. So we need 4 groups. So that means we're going to have 3 lines, which would give us our 4 groups. 1, 2, 3 lines gives us our 4 groups. So we now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have our 12 parts, which we needed. And we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 shaded parts. So now we have our 2/3 equaling our 8/12. So now the next part is drawing or expressing this equivalence as a multiplication sentence. To do that, what I want to do is do it as an addition sentence first, and then as a multiplication sentence. So I'm going to do 2/3 equals 1/3 plus 1/3, because that's how we started, 1/3 plus 1/3 equals, and each one of these now is 1/12, right? So I have, and I'm going to group them because this is now a group of 1/12s. So I have 4 1/12s into that 1/3, so I'm going to put those in parentheses. 1/12 plus 1/12 plus 1/12 plus 1/12, and that would equal 1/3, plus 1/12 plus 1/12 plus 1/12 plus 1/12. Again, I grouped those because that's what equaled the original 1/3. And I know all of those 12s, 1, 2, 3, 4, 5, 6, 7, 8, equals 8/12. Now, to think about this as a multiplication sentence, there's several ways we can do this. The quickest way to do this would be 2/3 equals 8, because there was 8 of them, times 1/12 equals 8/12. Another way to show this is 2/3 equals 4 times 1/12, showing that first grouping we did over here, plus 4 times 1/12, which is that second grouping we did right here, equals 8/12. That's just another way we could do that. Okay, for problem number 3, it says I can decompose to create equivalent fractions by drawing area models and dividing them into smaller parts. For numbers 1 through 5 is really something that would be done in class with a partner, so we're not going to do that right now. But we are going to go down to this next one where it says, how could we model 5/3. So we're going to draw an area model to show 5/3. So the first thing I'm going to do is draw 5/3. And to do that, I know 5/3 means more than 1, because I know if my numerator is greater than my denominator, that it is more than 1. So I'm showing this being more than 1. I know my total parts is 3, so I'm going to show my whole as broken up into 3. And I'm going to have that counting 1, 2, 3, 4, 5. So I can add another part on there to show that it's not completely done. So that's how I would show 5/3. Now, the next part says draw a horizontal line to model an equivalent fraction. So I'm going to draw a horizontal line right through here. How many units are in the whole? So I'm looking right here, and I'm looking at the whole. So from my whole, how many are in my whole? 1, 2, 3, 4, 5, 6. That's right, there are 6 parts in my whole. What is my fraction that is represented? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 that are shaded out of a total 6 parts. Because remember, we always give the total parts of the whole. And that will conclude the lesson for today.